Hello and welcome to the Data Science Dossier Unwrapped, the go-to source for all things data and technology. I'm Tom, and today we're diving into the fascinating world of data pipelines. Whether you're a seasoned data professional or just starting out, this episode hopefully is packed with insights to help you navigate this essential aspect of data management. In our data-driven age, efficiently managing and processing large volumes of data is not just important, it's essential for gaining valuable insights. This is where data pipelines come into play. But what exactly are data pipelines? They're a structured process that collect, transform, and deliver data from various sources to a destination for effective analysis and use. The goal? To ensure the data flows seamlessly, securely, and reliably. Let's take a hypothetical example to illustrate this. Imagine an e-commerce company aiming to analyze customer behavior and buying patterns. The data pipeline here would involve extracting customer data from multiple sources like website interactions, social media, and purchase history. This data then undergoes transformation to standardized formats and resolve inconsistencies. Finally, it's loaded into a warehouse for analysis. But what are the stages involved in a data pipeline? There are four key stages: extraction, where data is gathered from various sources; transformation, which involves cleaning and structuring the data; loading, where the data is stored in a repository or platform, ETL; and finally, analysis, where the data is interpreted to derive insights. Now, let's delve a bit deeper into the heart of the data pipeline, the ETL phases. ETL, as I just mentioned, stands for extract, transform, and load. This is where the magic happens, and it's fundamental to comprehending how data pipelines work. The extraction phase is the first step. This is where data is collected from various sources. It can be structured data from databases or unstructured data from files, web pages, emails, you name it. This step is critical to ensure the volume and the variety of data is necessary to make informed decisions. Next up is the transformation phase. This is where the collected data is refined. It involves cleaning, validating, and structuring the data into a format suitable for analysis. It's much like organizing a messy room into a neat, ordered space. This phase is crucial as it directly impacts the quality of the end analysis. Final stage is load. Here, the transformed data is transformed and stored in a data warehouse. This storage facility not only holds the data, but also allows for efficient retrieval and analysis. Consider it a library of data where you can pick and choose the information that is relevant for your analysis. These stages of ETL are the backbone of any data pipeline. Mastering them is crucial to ensuring the seamless flow of data, enabling businesses to make data-driven decisions confidently and effectively. But before you jump into developing a data pipeline, there are some critical questions to consider. What are your data processing goals? What formats will the data be in? How often does it need to be updated? And importantly, what are the security and compliance requirements? Let's dive into these questions a little bit more. First up, your data processing goals. Are you aiming to improve operational efficiency, drive new revenue, or perhaps enhance customer experiences? Identifying your goals will help guide your data pipeline strategy and help in determining what data is most relevant. Next, consider the formats of your data. Will you be working with structured data such as SQL databases or unstructured data like emails, videos, social media posts, and so on? Understanding these formats will help direct your transformation phase. Equally important is the frequency of data updating. Is your business dependent on real-time data or can it operate on batch processing? The answer to this will influence your choice of ETL tools and strategy. Lastly, never overlook the importance of security and compliance. What are the legal and regulatory requirements for your industry? What measures do you have in place to protect sensitive data? The load phase of the ETL process must ensure that data is not only stored but also secure. These questions might seem complex, but they are fundamental to developing an effective and efficient data pipeline. Remember, the end goal is to make better data-driven decisions for your business, and answering these questions is a step in that right direction. Now, when it comes to developing data pipelines, several programming languages stand out, like Python, Java, and Scala. Python is known for its simplicity and readability, making it a favorite both among beginners and experienced programmers. Then there's Scala, built on the Java virtual machine, which is great for handling large data sets and parallel processing. Now, let's discuss why Python has emerged as a leader in pipeline development. Python's popularity in data pipeline development can be attributed to its powerful libraries like pandas for data manipulation, NumPy for numerical computation, and matplotlib for data visualization. These libraries and more simplify and accelerate the development process to a great extent. Additionally, Python's syntax is easy to understand and write, which contributes to a faster development cycle. This readability also makes Python code easier to maintain and debug, leading to more robust data pipelines. Furthermore, Python's supportive and active community is always ready with solutions and updates, fostering continuous learning and development. This community makes Python a dynamic and ever-evolving language, keeping it at the forefront of data pipeline development. Ultimately, it's Python's adaptability, ease of use, robust support system that have established it as a go-to language for data pipeline development. But always remember, the right tool depends on your specific needs and circumstances. While Python is undoubtedly a powerful tool in pipeline development, Scala has also carved out its own niche in this field. One of the major advantages of Scala is the seamless integration with the Java ecosystem, which allows it to handle large data sets and perform parallel processing remarkably well. Scala's functional programming features like immutability and higher order functions contribute significantly to creating complex data pipeline logic with fewer lines of code. This results in concise, readable, and maintainable code, which is crucial in pipeline development. And it's also a bit addictive trying to figure out how small you can compress that code. Additionally, Scala's static typing system helps catch errors at compile time rather than runtime, which boosts reliability and reduces debugging time. This, combined with its excellent concurrency support, makes Scala an efficient tool for building high-performance, fault-tolerant data pipelines. So in short, Scala's scalability, functional programming capabilities, and compatibility with the Java environment make it a strong competitor in the world of data pipeline development. Again, the choice between Python and Scala should be guided by the specific requirements and the context of your project. In terms of tools, we have platforms like Databricks, Apache Kafka, Apache Airflow, AWS Glue, Google Cloud Dataflow, also known as Apache Beam. Each of these offers unique features for data integration, scheduling, monitoring, and error handling. Let's talk about Airflow. A standout tool in the realm of data pipeline development, Airflow offers the power of programmatically authoring, scheduling, and monitoring workflows, allowing for complex pipelines to be developed using Python. This means you can control the minute details of your pipeline, building its dependencies, checks, and balances, and handling errors effectively. Another compelling advantage of Airflow is its active and supportive open source community, which is continuously contributing to its development and improvement. Plus, it's designed with scalability in mind. enabling you to manage and orchestrate vast amounts of data with ease. The, this combination of power, flexibility, and scalability makes Apache Airflow a potent ally for any data pipeline project. Now let's focus on Google Cloud Dataflow, another prominent tool in the field of data pipeline development. Dataflow is a fully managed service for transforming and enriching data in real time and batch modes, which with equal reliability and expressiveness. Its serverless approach abstracts the underlying infrastructure, letting you focus on developing, deploying, and optimizing your pipelines without worrying about system management. Therefore, developers can devote more time and energy to their core competencies. Furthermore, Dataflow's seamless integration with other Google Cloud services such as BigQuery and PubSub enhances its utility in developing comprehensive cloud-native data pipelines. It helps users easily process, analyze, and derive insights from their data in a timely manner, empowering informed decision-making. In summary, Google Cloud Dataflow offers an efficient, intuitive, and integrated solution for developing sophisticated data pipelines, ensuring that your data is accessible, usable, and valuable. Turning our attention to another entrant in this list, Databricks Delta Live Tables, which are pretty new in the Databricks ecosystem. This is a highly collaborative end-to-end data pipeline development and automation tool that has streamlined the process of building, deploying, and maintaining data pipelines. Delta Live Tables offer an abstraction over the complexities of pipeline development, enabling developers to focus on defining transformation and business logic, reducing the time and effort needed to bring data into action. The tool has built-in reliability and data quality enforcement mechanisms, including schema checks, anomaly detection, ensuring the highest level of data accuracy. Further, it's integrated with Databricks' Lakehouse platform, which enables easy access and analysis of both real-time and historical data. With its automation capabilities, it supports continuous integration and delivery, allowing frequent updates and iterations. Therefore, Databricks Delta Live Tables provide a comprehensive, reliable, and efficient solution for designing modern data pipelines, helping businesses unlock the full potential of their data assets. So it's important to note that data pipelines have evolved as a more flexible and scalable alternative to traditional extract, transform, load, or ETL processes. They're capable of handling real-time data processing, which is crucial for timely decision-making. Real-time data processing plays a critical role in contemporary business decision-making. It empowers organizations to respond to market changes, customer behavior, and internal dynamics almost instantaneously. This agility is crucial in today's digital and fast-paced business landscape. With real-time data, businesses can identify trends, patterns, and insights as they emerge, enabling them to make informed decisions quickly and effectively. For instance, e-commerce companies can dynamically adjust pricing or promotions based on real-time demand patterns, while financial institutions can detect and respond to fraudulent transactions immediately. Similarly, manufacturers can monitor equipment performance in real time to predict and prevent failures. Hence, the ability to process and analyze data in real time can lead to operational efficiency, customer satisfaction, and ultimately a competitive edge. To sum it up, data pipelines are indispensable in today's data analysis landscape. They ensure the availability of accurate, timely, and reliable data, enabling efficient processing and empowering businesses to make informed decisions. And that brings us to the end of today's episode. We hope you now have a clearer understanding of data pipelines and feel confident in leveraging them in your data processing workflows. Stay tuned for more insights and discussions here on the Data Science Dossier Unwrapped. And until next time, keep exploring the power of data.